Okay, so today, if you really see, I think climate change is no more a speculation, right? It's the biggest challenge that in this era that we are facing. Like Raman mentioned, uh, unprecedented flood, drought, and whatnot. I think these are things that you witness on a day-to-day basis. It is not that it is just being a theory kind of a thing. So, and in reality, a lot of things can be done at a design stage, which may probably cost you a 2 to 5% additional cost in case if you have to retrofit it with all the demand for net zero from occupiers going up. So retrofitting may cost a lot more compared to doing it in the design. So the entire thing is obviously there is an advantage if you can address most of the things during the design stage. I'm not against retrofitting, but then you can be futuristic. You can do things ahead of times, just not for certification purpose, just for but for the good of the whole society. That's the most important thing. And often you hear a terminology called as VUCA today. VUCA stands for, it's a VUCA world. They say VUCA is volatility, uncertainty, complexity, and ambiguity. And because of all the geopolitical situation, you can see that it's a VUCA world. And sometimes people start wondering, should I really focus on sustainability with the VUCA world? Actually, sustainability becomes more critical, not less in a VUCA world. I mean, that's something that we need to really understand. Uh, and why is it important? If you see, it actually amplifies sustainability's importance, whether it is building resilience against volatility or managing long-term uncertainty or competitive advantage through anticipation. All these are really factors that ensures that I mean, sustainability is important even in the VUCA world. Uh, so if you look at real estate emissions, obviously real estate emissions is buildings contribute to a significant percentage of emissions. And World Green Building Council had talked about both operational carbon as well as embodied carbon quite some time back, not very recently. If you see, they had an ambition that all the buildings must be net zero embodied carbon and operational carbon by 2050. And typically, the reduction is anticipated to be about 40-50% lower compared to the current. I mean, 2020 is probably, if you can look at that as a baseline. So I mean, this is something that I mean, that is a whole life carbon vision, which is pretty important. So today, embodied carbon is just started getting addressed. Of course, India as a country, we have committed to be net zero only by 2070. But that doesn't mean that we are insulated from what's happening in Europe or other parts of the globe. And when investors come from other parts of the globe, they obviously emphasize on aspects related to embodied carbon as well. So when you look at embodied carbon today, if you look at it, out of the 40%, when we talk about typically about 10% of global commission, global carbon dioxide emissions come from building materials, which is what I'm talking to you as the embodied carbon. So the kind of cement, the kind of steel, all the structural things that go into a building obviously is getting a lot of focus today. Uh, this is how it is defined essentially. If you can see A1 to A5, and which is called as the embodied carbon, which is often referred to as the cradle to gate. I am seeing a lot of focus compared to operational carbon. The embodied carbon is also getting attention these days. And the advantage is if you have early engagement, that can be a potential cost savings. And these are typical examples, the range of embodied carbon numbers. In a commercial office building, it could be 400 to 800. Sometimes this is not even including the mechanical and electrical equipment. If you include those things, it can even go up to something like 1200, 1300. These are typical numbers. But today, people are able to achieve the lower spectrum. Like, for example, people are able to achieve an embodied carbon for materials at 400 kg per carbon dioxide per meter square of a commercial building. And similarly, for a fit out, it could be like as low as 150. But things are evolving as I'm speaking. So circularity, which is circular design, can happen through material selection, structural design. Low carbon concrete makes a whole lot of things. Often life cycle assessment is missed out. So you do have to look at life cycle assessment and integration at a design stage, not as post design validation. Otherwise, it becomes an expensive affair when you do it post as a post design thing. Some of the design aspects, obviously, in 8 minutes, I'm just going to give a very brief thing. Obviously, doing it right is very important. It could be to do with the envelope design, or it could be to do with passive architecture or advanced cooling technologies, or it could even be as good as an enhanced filtration system. There is something called as an ISO 16890 rated filters available in the market today. hardly a few of them use it today. I mean, but typically the advantage could be as high as 25-35% higher performance with respect to energy, water, and waste going to landfill, avoiding waste going to landfill. So with that, I'll pass here and hand it over back to Sri Parvati. Thanks again.